Okay, so you did the uniform distributed load as a point load 120, and then you should put the AY and the CY, and then later on you just put this dimension 3 meter, because it's the whole thing. The uniform distributed is 6 meters, so it's half 3 meter and half 3 meter from point A, and from point B is 3 meter. And then CY is the rest of the dimension 3 meter. The best is to take, as you did, summation moment at A. Summation moment at A will give you CY 40 kilonewton. And then you do summation of forces at Y, and this will give you CY of course, this is CY, and summation of forces at Y, you will get AY is equal 80 kilonewton. So I have to put here kilonewton. And then you put the lines for the shear diagram. What did I see in your shear diagram that it was wrong? You start from this point. This is a hedge. So you start from 0. So you go 80 kilonewton up. Okay, so you start with this 80 kilonewton up, and then you can see here it is a distributed load. Remember, this is the point load from the distributed load, from here to point B. So you go 80 minus 120, because it is a uniform, so you're gonna go linear all the way to point B. So 80 minus 120, and that is minus 40. Remember, if you have a uniform distributed load from point A to point B, if it is uniform load, now the shear would be linear. خط مستقيم, linear. 2 minus 40. 80 minus 120, and that is minus 40. And since from this point to this point, there is no loading. Go back to the figure, you'll see that there is no loading here, which means that shear would be uniform. Shear would be constant. So it was minus 40, it will stay minus 40 until it comes to this point. And since here you have 40 up, so minus 40, you go up 40, and that's a good check. You will come back to 0. You start from 0, you go back to 0. Hinge to a ruler. Now, the main idea of this is to find the area of this shear diagram. This point, remember, this change over from a plus to a negative. We need to find out this point. You can see that this is 80 and this is 40. So 80 plus 40, that is 120. So I make the big triangle 120, and since this big triangle is 120, this side is 6, 3 and 3. So we have 120 and in the vertical and 6 in the horizontal. And let's find this distance. So this is 80, and this is unknown because I found this. This is unknown, so 80 and x. So you do the triangles, similar triangles. X over 6, 80 over 120. So x would be 4 meter, which means that we found that this is x 4 meter. Once we found this, خلاص, 6 meter, this is 4, the rest is 2. Now we could find the area. 1/2 times 4 times 80. 1/2 times 4 is 2. Times 2 times 180, 160. So which means that you start from a 0 moment. And since this is linear, the moment would be non-linear. So 1/2 times 2, 2 times 80, that's 160. And that is in the plus. So non-linear until this point. And this is the maximum moment. So at this point, when there is shear is 0, the moment is max. And then let's find the other area here of this shear. 1/2 times 2, that's 1, times minus 40, that's minus 40. So 160 minus 40, and that is plus 120. So look at this is linear. So this is going to be non-linear. So this is 160 minus 40, that's 120, and this is non-linear. You come to this point, the last shear, this is minus 40. That's, of course, it's like a rectangle. Minus 40 times 2, minus 40 times 3, sorry, it is minus 120. And since it was 120 minus 120, and that is, look at this is uniform, constant. So minus 120 plus 120, that's going to give you to 0. okay? And look at this moment, all in the plus. And plus, you could notice the maximum moment is 160 kilonewton meter. This is non-linear. This is non-linear, and this is linear.